Last unit, we were given slopes and y-intercepts, or we were given an equation of the line y equals 2x minus 7, for example, and your expectations were that you had to turn that into a graph. Well, this unit is kind of the reverse of that. We're going to be given information, and our job is to turn it into an equation this time. When we write an equation of the line that passes through coordinates, or we're given slopes, or we want it to be parallel, it does not matter. We always need two pieces of information. We always need to find the slope and the y-intercept to write a line. This first example, I'm going to show you two different methods for solving these types of problems. It's important to be familiar with both methods. You don't have to memorize both. You can always use the ones that you are comfortable with. So for this example, we want to write an equation of the line that passes through the coordinate negative 8, 3. So that is an x and a y value, and has a slope of 1/4. That is a value of m. So as I said before, we always need two pieces of information. We need the slope and we need the y-intercept. We were given the slope, so we know the slope is 1/4. We need to figure out what the y-intercept is, and I'm going to show you two different ways. So the first method is using slope-intercept form, y equals mx plus b. We were given 3 out of the 4 numbers. So we were given that the y value is 3. The slope, or the m value, is 1/4. The x value is negative 8. And we are trying to figure out what our b value is. So I just substituted in the information that I was given, and then I'm going to simplify. So I'm going to multiply 1/4 times negative 8, which is negative 2. Everything else drops down. Then I add 2 to both sides to get a b value of 5. So now that I know the slope and the y-intercept, I can write my final answer, y equals 1/4 x plus 5. A second method is called point-slope form. It looks similar to slope-intercept. We're going to take y and subtract y1. That's equal to m times x minus x1. So I'm going to be plugging in for y1, the slope, and x1. So I have y minus, my y1 value is 3. That equals my slope, which is 1/4, times x minus my x1 value of negative 8. The first thing I want to take care of when simplifying, overall goal to get y by itself, but before I start simplifying, I want to turn these double negatives into a positive. Then we only have 2 steps and we're done. We're going to distribute through the 1/4, so that leaves us with 1/4 x plus 2. And then to isolate y, we add 3 to both sides, and that gives us our final answer of y equals 1/4 x plus 5. So 2 different ways to arrive to the same exact answer. You can either use slope-intercept form or point-slope form, whatever you are more comfortable with. Example number 2, write a linear function with the values f of 4 equals negative 2, f of 8 equals 4. So we're given different types of information. First thing I'm going to do is I'm going to write this as a coordinate, since most of us are more comfortable in that form. So we have 4, negative 2, and 8, 4. So we're given 2 x's and 2 y's. So I'm going to label this as x1, y1. It's my first coordinate pair. And x2, y2, my second ordered pair. We were given no information that we would need. We weren't given the slope, we weren't given the y-intercept. So we need to find both parts now. Remember or recall that our slope is our rise over our run. When we rise, we are looking for the change in the y. When we run, we're looking for the change of x. So that leaves us with the formula y2 minus y1 over x2 minus x1. Now, these subscripts do not mean anything mathematically. It doesn't mean to square or to multiply by 2. All it means is that is your second coordinate that you're working with. And the subscript of 1 means those are the first coordinates that you're working with. So I am going to plug in my values. So I have y2 minus y1 over x2 minus x1. I am just just substituting in my values. 4 minus negative 2 is 6. 8 minus 4 is 4. That reduces down to 3/2. And I have one piece of information. All right, I'm going to do this problem in point slope. If you prefer y equals mx plus b, you could solve that way as well. So I'm going to write down my point slope formula so I can substitute in the values. All right, so it does not matter if you want to choose the coordinate 4, negative 2 or 8, 4. You will still arrive at the same answer. Most of you probably want to work with 8, 4 because it doesn't have any negative numbers. So I'm going to choose 8, 4. So I'm going to substitute in y minus 4 is equal to the slope that we just found, x minus 8. 2 steps. I'm going to distribute. That leaves me with 3/2 x minus 12. And then add 4 to both sides. So my final line is y equals 3/2 x minus 8. Student Council is ordering foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands to the cost. So first we need to decide, can this situation be modeled by a linear function? So we need to see, does it have a constant rate of change? So my x values are going up by 2, up by 2, up by 2, up by 2. So my change in x is 2. My y values are increasing by 12 between every single interval. Therefore, my change in y is 12. So yes, because we're moving at a constant rate of change, this is a linear equation, or can be modeled by a linear equation. So they want us to write it. So we still need the slope, and we also need the y-intercept. So slope, as we said, is rise over run, which is change of y over change of x. We have found these pieces of information. So our change in y is 12, change of x is 2, and 12 divided by 2 is 6. We have 5 coordinates we can choose from: 434, 646, 858, 1070, 1282. It does not matter which value or coordinate you choose, you will still arrive at the same answer. This time I'm going to solve in slope-intercept form, and I'm going to choose the coordinate 1070. So my y value is 70. That's equal to my slope times the x value of 10, and we're trying to figure out b. So when I simplify, I multiply through, and then I subtract my 60 from both sides to get 10. Now that I have the slope, Now that I have the slope and the y-intercept, I can write my line, y equals 6x plus 10. Write an equation of the line passing through 5, -4, so that's my x and y value, and is parallel to y equals 2x plus 3. If two lines are parallel to each other, they never intersect. They never intersect because they have the same exact slope. So if I want to create a line that is parallel to 2x plus 3, I need to use the same slope as 2x plus 3. So I need to have a slope of 2. I also need to use the information for -4 since that is a coordinate on my line. So I'm going to use slope-intercept form again. My y value is -4. My m value is 2. X is 5. I add b, and I just need to simplify. So -4 is equal to 10 plus b. Once I subtract my 10 from both sides, I'm left with -14. So there's my y-intercept, there's my slope. Final answer, y equals 2x minus 14. Final example, we want to write an equation of the line that passes through -3, 1. So there is my x and y that I'm going to be working with. And this time we are perpendicular to y equals 1/2 x plus 3. Perpendicular lines are two lines that intersect, and when they intersect, they form a 90-degree angle. We learned in our Desmos activity that intersecting or perpendicular lines have slopes that are opposite reciprocals. So that means if this line is positive 1/2, the opposite reciprocal of that line is -2/1, which is just -2. So the slope that I'm going to use is -2. I'm going to finish up with point slope. And I'm going to be filling in for y1, x1, and m. So I have y minus 1 is equal to that slope of -2, x minus -3. Taking care of those double negatives, I'm going to distribute to get -2x minus 6, and then add 1 to both sides. So my final answer is y equals -2x minus 5.